In 1901, a group of Greek sponge divers, blown off course by a storm, dropped down to a rocky seabed near a tiny island called Antikythera. They were looking for sponges. What they found was a 2,000-year-old Roman shipwreck packed with treasure, bronze statues, glass, jewelry, coins. And in that hall, almost ignored, sat one ugly, corroded lump of bronze about the size of a shoebox. For months, it just sat in a drawer in Athens. Then one day, the lump cracked open as it dried, and inside, someone saw something impossible: a gear, a precise tooth-cut gear wheel. And then another meshed into it. This was a problem because gear work this fine does not appear anywhere else for another 1,000+ years, not until the astronomical clocks of medieval Europe. It was as if you opened a Roman tomb and found a pocket watch. It was not a clock. It was not a toy. It was a computer, a hand-cranked machine, 2,000 years old, that could track the sun, the moon, and the planets and predict eclipses years ahead, and it should not exist. So how did a Greek engineer put the entire sky inside a box you could hold? Before we open this thing up, look at what you already carry. Right now in your pocket is a device that knows the sky perfectly. Ask it what phase the moon is tonight. Instant. When is the next solar eclipse and will you see it? It gives you the date, the minute, the path across the earth. Where is Jupiter right now? Tap, and there it is. We treat this as completely boring. Predicting the heavens, the thing that terrified and obsessed every civilization for thousands of years, is now a free background feature we never think about. But feel how strange that is. To know where the moon will be next month, your phone runs a model of the solar system, the Earth turning, the moon swinging around us on a tilted, stretched orbit, the planets looping the sun at different speeds. It is doing astronomy silently, millions of times a second. Now here is the chill. 2,000 years ago, no electricity, no numbers as we know them, no printed math. Someone built a machine that did a version of the exact same job, not on a screen, in bronze, with gears you turn by hand. It modeled the sun, the moon, its speeding up and slowing down, and told you when the sky would go dark. The Antikythera mechanism is literally the great-great-grandfather of the little astronomer in your pocket. So let's understand why anyone would pour that much genius into predicting the sky. To feel why this machine mattered, remember what the sky meant back then. For us, the calendar is an app. For an ancient farmer, reading the sky was survival. Plant too early and a frost kills everything. Plant too late and the crop never ripens. The stars and the moon were the only clock big enough to run a whole civilization by Manas. When to sow, when to harvest, when the river would flood, when to sail, and when to stay in port. Get the sky wrong, and people starved. Then there were eclipses. Imagine you have no idea why the sun is being swallowed in the middle of the day. The world goes dark, the birds go silent, and it feels exactly like the end of everything. Whole armies stopped fighting mid-battle out of pure terror. Kings believed an eclipse was a warning aimed straight at them. So anyone who could predict one, who could stand up and say the darkness is coming on this day and it is normal and it will pass, was not just clever. They held a power that looked like magic. And the Greeks had one more reason to track the heavens. Their whole world ran on cycles. The Olympic Games, religious festivals, the calendars of rival cities, all tied to the sun and the moon, all needing to be counted and synchronized. So predicting the sky was worth staggering effort. It was farming, religion, war, politics, and identity, all bound up in a few lights overhead. That is the problem the mechanism was built to conquer. So back to how we found it. The year is 1900. A crew of Greek sponge divers sailing home from the coast of Africa gets hammered by a storm and shelters beside a barren little island called Antikythera. While they wait, they do what divers do. They go down to look. And 45 meters down, one diver surfaces in a panic, babbling about a heap of dead bodies on the bottom. They were not bodies. They were bronze and marble statues, arms, faces, horses, scattered across the wreck of a giant Roman cargo ship that had gone down around 60 BC, probably hauling looted Greek treasure back to Rome. It became the first major underwater archaeology dig in history. Over months, in heavy suits at crushing depth, the divers hauled up masterpieces: statues, glass, coins, jewelry. One diver died, two were paralyzed by the bends. And in all that dazzling haul, one object got almost no attention: a shapeless, crusty lump of bronze and rotten wood cracked into a few pieces. It was set aside in the National Museum in Athens, while everyone fussed over the statues. Then, months later, the wood dried and the lumps split further apart, and a curator noticed inside the corrosion the unmistakable shape of a gear wheel with tiny teeth and traces of a scale marked in Greek. That ignored lump was about to become the most important object ever pulled from the sea. Quick one before we crack it open. If a 2,000-year-old computer hiding in a shipwreck is your kind of story, that is this whole channel. Subscribe, and the next ordinary seeming thing gets pulled apart the same way. Okay. Here is the frustrating part. The mechanism did not survive as a neat machine. It survived as 82 corroded fragments, fused and crushed. The gears jammed together like a bronze fossil. For decades, no one could tell how many gears there were or what they did. You could not just pry it open, you would destroy it. The breakthrough came from seeing inside without touching it. In the 2000s, a team called the Antikythera Mechanism Research Project brought in a custom 8-ton X-ray machine to make high-resolution CT scans, slicing through the corrosion layer by digital layer. And suddenly, the ghost machine lit up. They counted the gears, at least 30, some with more than 200 teeth, cut by hand to a precision no one believed the ancient world had. Even better, the scans revealed writing, thousands of tiny Greek letters hidden across and inside the surface, a built-in instruction manual describing the dials and what they showed. Text nobody had read in 20 centuries became legible on a screen. Piece by piece, the scientists rebuilt it, not just the shape of the gears, but the astronomy they encoded, and what they found was breathtaking. So let's actually run it. On the front, there is a single hand crank. That is the only input. You turn it, and you are literally turning time. The crank drives a big main gear that stands for the sun moving through the year. From that one motion, the machine splits the power into gear train after gear train, each dividing or multiplying the turns to track a different rhythm of the sky. Follow it to the front dial. 2 pointers sweep around a ring marked with the zodiac and a calendar of days. One is the sun, where it sits among the constellations. The other is the moon, racing around about 12 times faster, and there is even a little rotating ball, half black and half silver, that spins to show the moon's phase as you crank. Now flip it to the back, and it gets almost unbelievable. 2 big spiral dials. The top spiral is a calendar of about 19 years, the exact cycle where sun and moon line back up, so the same phases fall on the same dates again. The bottom spiral tracks the Saros cycle, the deep rhythm of eclipses, with little marks that tell you when a solar or lunar eclipse is due and roughly what to expect, and a small dial just for the 4-year cycle of the games, including the Olympics. One hand crank in, the entire calendar of the sky comes out, so how do gears alone pull that off? But here is the detail that makes engineers gasp. The Greeks had noticed something subtle. The moon does not cross the sky at a steady speed. Sometimes it runs a little faster, sometimes slower, because its orbit is not a perfect circle. It is slightly stretched, an ellipse, so it speeds up when it is closer and slows when it is farther. The astronomer Hipparchus had worked this out mathematically. The impossible question is, how do you make rigid, evenly spaced gear teeth reproduce a speed that keeps changing? A gear turns at one steady rate. It cannot just decide to speed up and slow down. The answer they invented is so clever it was not rediscovered for centuries. They took 2 gears and mounted them on slightly different centers, offset, not sharing one axle. A little pin sticks up from one gear and rides inside a slot cut into the other. As the first gear turns evenly, that pin drags the second around, but because they are off-center, the pin sits closer to the axle at some points and farther at others, so the second gear is forced to turn faster, then slower, then faster again. A steady input, a deliberately uneven output. A mechanical trick that literally builds the moon's wobble out of 2 brass wheels and a pin. They did not just track the sky, they encoded a subtle law of orbital motion into metal 1,700 years before Newton would explain why it happens. Now step back and look at the whole timeline, because this part is genuinely haunting. The Antikythera mechanism was built around the 1st or 2nd century BC, and then nothing, no other object anywhere near this complex shows up in the record for well over 1,000 years. Geared astronomical clocks of this sophistication do not reappear until 14th century Europe. That is a gap wider than the entire history of Rome, of Byzantium, of the early medieval world. A 1,400-year hole where this technology simply vanishes. Think about what that means. This was almost certainly not the only one. A device this refined implies a whole workshop tradition. Earlier, cruder versions, skilled makers, apprentices, accumulated know-how, all of it lost. Whoever could build these died and did not pass it on. or their heirs were scattered by war and time. We do not even know for certain who made it. The best guesses point to the island of Rhodes, a hub of Greek astronomy, and to the tradition of Hipparchus, or even the school of Archimedes a little earlier. But the maker is anonymous. One of the greatest engineers who ever lived left us a masterpiece and no name. And it is a quiet, uncomfortable reminder. Progress is not a straight line upward. Knowledge is fragile. It can be built and forgotten and take 1,000 years to claw back. We got lucky that one shipwreck in one storm kept a single copy safe on the seabed for us to find. So the next time your phone quietly tells you the moon is waxing tonight or warns you an eclipse is coming, hold that thought for a second. You are looking at the far end of a line that starts with a bronze box and a hand crank on a Greek workbench 2,000 years ago. Strip away the screen and the silicon, and the core idea is exactly the same. Take the motions of the heavens, huge, slow, terrifying, sacred, and fold them down into a machine you can hold in your hands and simply read. Every mechanical clock that ever ticked is a descendant of that idea. Every gear-driven calculator, every planetarium, and, in a straight conceptual line, the computer you carry in your pocket. The Antikythera mechanism is the moment humanity first proved that the universe is not only something to fear and pray to, it is something you can measure, model, and predict with nothing but clever hands and metal. They could not stop the eclipse, but they could look you in the eye and tell you the exact day the sun would go dark and promise you it would come back. That is the whole story of technology in one object, not power over nature, but understanding it well enough to stop being afraid. A Greek engineer put the sky in a box. You put it in your pocket. That is the everyday equation. I will see you in the next one.